So last week we started covering Web API, and we created this user registration controller inside of our project. And I briefly covered the fact that you've got 4 main HTTP methods that handle all of your calls. You've got the get, post, put, and delete. And those align with what I like to call the 4 CRUD operations: create, read, update, and delete. So create is to actually make something new, read is to get something out, update, and delete. Get is to read, get something out. I always get these confused. Put is to insert or create something. You want to put something new in. Post is to post an update to that object, and then delete is again delete. So what you're doing here is you're creating sometimes 4, sometimes 5, and I'll get into the semantics later, but you're wanting to replicate those operations using the HTTP methods. The goal is that depending on the call you make, depends on the action the controller takes. So these names aren't like when we were doing controllers and actions, where we had a controller / an action and it had a unique name. These names are completely related to those HTTP operations. So if your call to this web address is a get call, then you're implementing the get routine. If your call is a put call, then you're implementing or calling the put routine. You're calling the same URL, but the method is what identifies which one of these functions gets called. And I'll show you some of that in a moment. So we started out by just doing a get based on session. So what this was doing is it was pulling the user registrations based on a particular session ID. So we go in, we grab user sessions as a list, hook up to our context. We say get the session, so we actually go out and do a first of default on the session ID. So we're doing a select here basically, grabbing the selected session. And then underneath that, we're saying select all of the users. Select all of the users out of those sessions. So we're walking from session to user sessions, that one to many. And then from user sessions, we're then grabbing all of the user objects. I then created a user web API view model. I then pack all the user data that I want to present into that view model, and then I call toList. That list gets I get basically a list of user web API view model objects that represent my users. And then I return. So on the browser side of things, I access that by going /API /user registration !, session ID, which is the name of my parameter, equals 1. And when I make that call, the server returns back to me those objects formatted in the format that is identified in the header of my request. All right, so just hold that concept with me for a second. So what I get back is there's only one user, so I get back an XML array of user web API view model, which basically says here's the first name, last name, and username for that user. I only have one user, therefore I only have one object. Oops. So let me jump back, and I'm actually going. Hang on one second. I think I've got a API. Solution routes. Let me get this out of here. So when I was working last week, I set up a route. I was trying to configure my routes myself. I think I broke it.
All right. So let me create another account. Guess my link is bad. What do I call my controller? Registration. That's right. Oh, it's on home. So what I have here is my registration link is going home/registration. So what I need to do is go to my view, shared, layout. And this should actually be index of registration. So what I had before was registration home. So I was pointing, so it's action, comma, controller. So I was pointing to a registration action on the home controller, which does not exist. What I wanted was the index action on my registration controller. That generates my registration link at the very top of my page. So let me reload, go back to registration, and I'll sign up for session 1 as well. So the reason I'm doing this is I want to see 2 users come back from my web API call. All right, there we go. So now I have 2 users coming back. I have my first one, and then I have a Kevin Gantos 2, basically. So this is how those 2 user objects get serialized into XML. So does anybody know the obvious question to ask? No? Well, the obvious question I would ask is, why did it come back as XML? Huh?
Is that what your API is defaulting to return?
No, actually it's not. The API will return whatever the client is that calls it says it consumes. So because my client is a web browser, the browser consumes HTML or XHTML or XML type text. That's determined based on these header requests and responses. So I pulled up, I think I pulled this up a few times. This is the Chrome Developer Tools. So under network, I'm clicking on the request here. And what I'm looking at is this request header. So there's a lot of garble in here, a lot of different pieces. But the piece that's of interest is this accept header. It says that it will accept text/HTML. This is what the browser is telling the server. I'll accept these formats. Text/HTML, application/XHTML plus XML, application XML. I do not know what the Q09 thing is. Image WebP, and then basically I think that's saying whatever else you want. It handles it as just a binary. So what's happening is that Web API is reading this line, is looking at that array of users that we're returning, that list of users, and it's saying, what format can I return it in? That would make the most sense, that would provide the most integrity to the content requested. Okay? And it sees application XML, and it says, I can encode this into XML. And that's why we get an XML response. If we actually just right-click and say View Source, this is literally what comes back from the server. It's just a straight string of XML. So you may ask, okay, well, what's that good for? Well, we can now consume this. So XML is a data document format. So we can call from another computer, another device, and say,
give me this information, and we can consume it and use it programmatically. We can do it from our server, so we can have two servers that talk to each other. So web services sometimes are used for server-to-server communication. One acts as the server, one acts as the client. So server A is the client saying, hey, server B, I need all of the users that are registered for this session. Or if you want to think of a real-world scenario, it would be I'm a ordering system and a shipping system. Well, the shipping system needs to know what orders need to be filled, right? So instead of a person printing out a bunch of orders and walking over to the shipping guy and giving them to him, wouldn't it be great if the shipping system could poll the ordering system every minute, every hour, every 5 seconds, your Amazon, or probably even more frequently, and say, what orders need to be shipped? And that ordering system's web service can then turn around and say, here's a list of all the orders that have been recently placed that have not been marked as shipped. And that could include the order information, the shipping address, the items to be shipped, and all of that could be serialized into an XML format that the shipping system can then interpret and process. And Amazon with their drones and little robots go around and they pick up the boxes and stick them in a big box and put them on a truck somewhere. That's realistic. I don't know about the little robots, but I've seen videos. So, that's the idea. So how do you get these systems to be able to talk to each other? So that's one scenario. Another scenario that may be a little more near and dear to your heart, depending on where you keep your phone, is a mobile app. Your mobile apps basically are nothing more than the front end to one of these web services. So if you pull up Facebook on your phone or Twitter on your phone or many of your games that you may play, all of those are just nice GUI front ends, GUI, graphic user interface, that then connects to a web service on the back end. So when you pull up Facebook, you're obviously not pulling up the Facebook website. The Facebook app is making web service calls back to Facebook saying, give me all of your friends, give me all of your chats, give me all your notifications, give me whatever, and it gets sent in this format. URLs for images, or sometimes they may just straight encode the image right inside of the XML and ship all of that over the Wi-Fi, over the cellular, right to your phone. The app then parses all of this and structures it on the screen so that it looks the way that you expect Facebook to look. The third scenario that's most common is that this would be the back end to a browser-based client. You may look at me and go, well, what's a browser-based client? Well, Facebook is another good example of that. If you use Gmail, or even probably the Outlook mail you guys use at UC now, is very much a single-page browser-based client. Basically what happens is you navigate to a site. That site consists of maybe one or two or a small number of web pages, but those pages are completely dynamic. So when you interact with that page, it's actually making calls back to the server, fetching this web service content, making these get, put, post requests to process your mail, your chats, your random image uploads, whatever they are. So these web services drive all of that so that you're not navigating through web pages all the time.